Welcome to Get Your FRQ On. This question is from 2011. It's question 2, and it is calculator active. In the question stem, we have a table of values for a cooling pot of tea at different values between 0 and 10 minutes. In part A, we are asked to approximate the rate at which the temperature of the pot of tea is cooling or changing at time t equal 3.5. So to do this, t equals 3.5 is not one of the values in the table. So what I would typically recommend is choose the smallest interval from the table that contains t equals 3.5. In this case, that would be using values of t for 2 and 5, and then using the average rate of change formula for t equals 2 and t equals 5. So the rate at which the temperature is changing at t equals 3.5 would be approximately equal to the temperature at t equals 5 minus the temperature at t equals 2 divided by 5 minus 2. It turns out that is negative 8/3 degrees Celsius per minute. Don't forget the labels here. They are, unless specified, you should assume that you do need a label just to be safe. In part B, we are asked to use a trapezoidal sum to approximate the value of 1/10 the integral from 0 to 10 of h of t dt and to explain its meaning with the correct units. So using a trapezoidal sum to find this integral, we need 1/10 of whatever the value of this integral is, and because we're using a trapezoid sum, we may have different widths. We have to take the average of 2 of the consecutive endpoints. So setting up this work, we have 2 times the average of 66 and 60, 3 times the average of 60 and 52, 4 times the average of 52 and 44, plus 1 times the average of 44 and 43. These are just the widths provided in the table, 0 to 2, 2 to 5, 5 to 6, 5 to 9, and then 9 to 1, 9 to 10. And then using our calculator, we can figure out what these values are. It is a calculator active question, so you can use your calculator to find that sum. Right, so that is the value of the integral. Then we want 1/10 of that. So 529.5 divided by 10 is 52.95. What does that mean? Well, notice that the structure of our integral is an average value integral. So this would be the average temperature of the pot of tea over that first 10 minutes, or t equals 0 to t equals 10. So the average temperature of the pot of tea was 52.95 degrees Celsius between t equals 0 and t equals 10. Always be careful about specifying an interval like this, t equals 0 to t equals 10. The first 10 minutes might be okay. T equals 0 to t equals 10 will definitely be okay. But something that doesn't pin that interval down, like it's the average temperature of the pot of tea over the 10 minutes. Okay, which 10 minutes? It is a good idea to be very specific when identifying these intervals for story problems like this. You don't want to leave it up to chance. Be specific, make sure you earn those points. In part C, we are asked to evaluate the integral from 0 to 10 of h prime of t dt, explain its meaning, and provide the units. So the integral that we're trying to find here is of the derivative of h, which means h is an antiderivative of this function. And using the fundamental theorem of calculus, the integral from 0 to 10 of h prime of t dt is just going to be h of 10 minus h of 0. Those are in the table. So h of 10 minus h of 0, using the values in the table, is 43 minus 66, which is negative 23. All right, so that would be the value of that integral. What does it mean? Well, h of 0 was the temperature of the pot of tea at t equals 0. H of 10 is the temperature of the pot of tea at t equals 10. And the temperature went down 23 degrees Celsius, so the meaning is, from t equals 0 to t equals 10, the temperature of the pot of tea dropped 23 degrees Celsius. In part D of this question, at t equals 0, biscuits were 100 degrees Celsius, and we have this function b prime of t equals negative 13.84 e to the negative 0.173 t, which gives us the rate at which the biscuit's temperature is changing. At t equals 10 minutes, how much cooler are the biscuits than the tea? All right, so basically we just need to find the temperature of the biscuits and the tea at t equals 10 minutes. Okay. We're given the temperature of the tea at 10 minutes. That's in the table. It's 43 degrees Celsius. The temperature of the biscuits is going to require a little bit of calculus. All right, so to find the temperature of the biscuits at t equals 10 minutes, we have to take the initial temperature, 100, and add the definite integral from 0 to 10 of b prime of t dt over that same 10-minute span, 0 to 10. All right, so this is a calculator active question. We're going to need our calculator to do this. When we actually calculate 100 plus this integral, we get 34.18275. But that is the temperature of the biscuits. That's not the actual answer to this question. The question is, how much cooler are the biscuits than the tea? So we still actually have to do a subtraction problem here. At t equals 10 minutes, the biscuits are 43 minus 34.18275 degrees Celsius cooler than the tea. It turns out it's 8.817 degrees.